Hi, in this video we are going to talk about the scientific method. But before we talk about the scientific method, I want to talk about science in general. We know that certain disciplines are called as sciences and certain other disciplines are not called as sciences. For example, physics, chemistry, biology, geology, archaeology, or even political science, social science, and these are things which are called as a science disciplines. And there are many more. These things could serve as examples for our discussion. And there are other disciplines which you do not call as sciences. For example, Tamil, English, Hindi, accountancy, mathematics, arts, literature. These things are not called as sciences. It may surprise you to know that even mathematics is not called as science. It is the language of science, but it is not science in itself. Mathematics is what you use to understand science, but mathematics in itself is not science. So you have, on the one side, disciplines which you call as science, and on the other side you have disciplines which you do not call as science. What makes this distinction? What causes this difference? Why do you call physics and chemistry and biology as sciences while you don't call poetry as science? Actually, if you think about it, you bring yourself to call even social science, history, as science. If history can be called as science, why not poetry? What does, say, Rajaraja Chola have in common with Isaac Newton that Thiruvalluvar doesn't have? If studying about Rajaraja Chola can be called as social science, why not studying about Tirukkural called science? To answer this question, you need to understand what makes science. First, the definition of science you may know. Science is about knowledge, to know things, knowing the truth about things. Those things you know already. But that is not the complete definition of science. That is how it has got the name science. Science is to know, right? So that is how it got the name science. But for a discipline to be called as a science, it has to meet one indispensable criterion. And that criterion is the adherence to the scientific method. Every discipline will have a common body of knowledge. Physics has a common body of knowledge. History has a common body of knowledge. Mathematics also has a common body of knowledge. Everything has a common body of knowledge. Arts, literature, dances. Even you take Bharatanatyam, it has a common body of knowledge. It has mudras and other things. You take martial arts, it has a common body of knowledge. If you take karate, you have katas and stuff. And you have common body of knowledge in each and every discipline. So that is knowledge, right? So if it is knowledge, can it not be called as science? Because science is to know. The answer is no. The knowledge should have been collected through what is called as a scientific method. Only disciplines which collect their knowledge using this method would be called as sciences. And that is a commonality between history and physics. That is how you tie Rajaraja Chola with Einstein. If a discipline does not use a scientific method, that discipline would not be called as science. Simple. And that is why you are not going to call Thiruvallur a scientist. And the study of Tirukkural is not science, it's poetry. So what is this method? What is this scientific method? And how do disciplines get to employ them? The scientific method is nothing but common sense. But common sense on steroids. It's heightened common sense. Very intense common sense. An intense application of common sense. That is science. The scientific method is not something which comes from heaven. It's not esoteric. It is not something you cannot understand. It's just plain common sense. We apply that on a day-to-day basis. We apply the scientific method to conduct our own affairs, to come to conclusions. We do that all the time. Let me try to explain that with an example. Suppose you're living in an apartment and you have a roommate. Suppose you're a male. I'll take a male example because it's easier. So you are a male and your friend is also a male. So you guys are sharing a room, an apartment. So your roommate is a nice fellow. Was very a trustworthy guy, is loyal, basically an honest guy. As honest as you can expect any decent human being to be. So he's that kind of a guy. So this goes on for some time and suddenly he starts disappearing between 4:30 in the evening to 6:30 in the evening. For 2 hours, you can't see him. He does not stay in the apartment. He's not there. So 1 day or 2 days, you're okay with it. But then this happens continuously. Then you watch it for a week or so, then you ask him, why are you not at the apartment at the time? Where do you go? Because I don't see you from 4:30 to 6:30. You're after communication. I never get to see you during that time. What's going on? And then your friend tells you this. I have a training in my company during the time. So 4:30 to 6:30 is the training time. I attend a training and then I come back home after that. And that is the reason I'm not at home. This is a reply your friend gives you. Then you take it at face value. You're okay with it. Okay, fine. Oh, that's the reason. This guy is not there during the time. That is how you understand the whole thing. Yeah, you had a question. You observed something. Something was not okay. Something piqued your interest. So you had a question about it. You wanted to know why this was happening. So then the best way to go about knowing the answer for that question is to ask your friend, what is happening, and then you did just that, and he gave you the answer, and you're okay with it now. So you observed something, you asked a question. You wanted to know why this was happening. So you asked a question, so this guy has given you the answer. So far, so good. And for the next 1 week, things go on as usual, in the sense that this guy is not present at the apartment from 4:30 to 6:30. He comes back only after 6:30. But you observe something else. It's not that you consciously observe, but it just strikes you in the face. This guy comes back very happy. Every day when he comes back, he's on cloud 9. He's so happy. And that doesn't seem to fit in the picture that he gave you. When he told you why he was absent, he told you that he was attending a training in his company. But now, he doesn't look like a person who is coming back from training. Okay? Think about it. When someone comes back from training, you expect that person to be gloomy, dull, tired, and all that. But this friend of yours, when he comes back very, very, very happy. So something does not fit in the picture. He doesn't sound like someone who is attending a professional training and coming back from office. So what you do, you want to figure it out yourself. So you try to follow him one day. He leaves the apartment, you follow him. He goes to the mall, a shopping mall. You keep observing him from at a distance. It looks like this guy is waiting for someone to come. He goes there, does nothing, stands for some time looking at his watch quite frequently. So he gives you the impression that he is waiting to meet someone. And after some time, a girl appears. She comes, she smiles at him, he smiles back, and then they chat a bit, and then they vanish into a coffee shop, and they come out after some time. You keep observing all this from a distance. And what he does is that he gives an envelope, a cover he has in his hand, to her, and then she gives a cover in turn. He gets that cover, and both are happy and smile at each other, and then they leave. So now you are convinced. Okay, the reason why this guy is happier than normal is because this guy is meeting this girl. So this guy is in love with that girl, and they're exchanging things every day. Maybe he gave her a letter or something, or a present. You have no idea what it is because it was in an envelope. And maybe she gives him something from her side. So they exchange kind of gifts and then leave. So they must be in love, and this is what piques your interest. So it also gives you the answer to the question of his being happier than he ought to be. So clearly, the answer of him attending a training session does not fit in this case. But this guy, in love with another girl, makes sense, and that explains a lot of things. Generally people in love are happy. They're deliriously happy. They are on cloud 9 all the time. And they totally ignore the world. So all that seems to be fitting with this picture, whatever this guy is doing. So you come to that conclusion, that this guy is in love. So this goes on for some time. And then for the next month or so, you observe something else in his behavior. He just does not seem to be a person who is in love. He behaves a little weirdly. He is totally oblivious to the world. Even when you talk to him, he doesn't respond to you at times. He's in his own world, smiling. He doesn't talk to you all that much either. And you observe this third phase. Then you think something is not right. It's not okay. A person, even if the person is in love, will definitely respond to questions. He will definitely talk to his friends. But this guy doesn't seem to be normal. Something is off-putting. Something is not right about the whole thing. It doesn't seem to be just love alone. So what you do, you start searching for things in the apartment. Then you open his drawer, table drawer, and you find one of those packs, one of those envelopes. You look into those envelopes and then you find that this guy is having heroin, a narcotic substance. Then you're shocked. So this explains a lot of things. This explains that the girl whom you saw with him in the mall is not his lover, but just a peddler of drugs. And he is getting drugs from her, and that is the reason why he is deliriously happy. And he doesn't listen to you because he can't pay attention to the world around him. And you cannot make out that this guy is in delirium because you don't get any smell. Okay? So if somebody takes alcohol, then you can clearly find out that this guy is intoxicated or inebriated because the smell of alcohol will give him away. But here, it's nothing of that sort. Like this guy just took the heroin and there was nothing that was giving him away. But now you know why he was behaving like this. Let me stop the story here. What you're going to do next is completely irrelevant to our discussion here, but at least you'll get this story. What has happened here, first of all? You observed something. You observed that your friend was absconding from the apartment during that time. So it piqued your interest and you tried to know the answer for that question. So you approached it in a certain way. You talked to him directly and then you got some answers. So based on that answer, you are trying to explain the observations. And then the further observations did not fit the story that he gave you. So you conducted your own experiment. You went behind him. You followed him. You tried to see what he was doing. And you figured out that he was not attending any training, but that he was talking to a woman very happily. So you concluded that this guy was in love, and that explained a lot of things for you. But that again was not the whole story. Further observations told you that there is more than meets the eye. So you looked for more evidence, more observation, which would fit this story or which would contradict this story. So you're doing something else to get more observations. So this time you searched in his table drawer and then found heroin, a drug. So that kind of explains everything that has gone on up till now. This, believe me, is a scientific method. I've taken this extreme example to explain that to you. But this is something that you would be doing on a daily basis. Every day, this is what you would be doing. Like whether you're waiting for a bus, whether you're planning to board a train, try to get an air ticket, or if you're trying to decide in which restaurant you're going to eat food, which movie to watch, or which guy to be friends with and which guy to fight with. When you are trying to take your decisions, you would be employing something like this. You will try to observe either the person or the incident more and more, and then you will form your own ideas about it, because you try to understand why this is happening or why that person is in a certain way. And you form your own hypothesis. You'll say that this guy is a good guy or a bad guy. This is a good restaurant or a bad restaurant, based on whatever you've seen. And based on that, you will take further action. And as you keep dealing with that person or the place or the event, you will get to know more about it. So your understanding of either the person or the event or a thing will get better and better with your experiments, I would call. Okay? So this is something that you do on a daily basis. But you don't call this as a scientific method. But trust me, this is a scientific method. The scientific method has 3 parts to it. One is observation. Second is hypothesis, or proposing a solution. Proposing a hypothesis, proposing a reason for why this is happening. And the third leg is testing. You test the hypothesis to see if it is still correct. You keep testing it. So long as the hypothesis meets your test, that has validity. But the moment it does not meet the test, when it fails the test, then the hypothesis has to be corrected. Your explanation is not correct. So the scientific method has these 3 parts. You observe something, like you observed your friend, and then you come up with a hypothesis, like as you came the first time, that this guy is attending a training, because you just believed him, whatever he said. Or as you came up, for the second time, with the explanation that this guy is in love. So that you came up yourself with. Okay. So you observe something, and then you come up with a hypothesis, and then you keep testing it. You see if this hypothesis is right, what should happen, and is it happening? If it is not happening, then why is it not happening? So these things are called as testing. Okay, so the 3-leg process, as I said, observation, hypothesis, and testing are a must. They form the scientific method. Well, different textbooks will have slightly different explanations for this, but basically this is it. There are only 3 steps involved. Sometimes they'll say 4 steps, but you don't have to worry about it, because one of these steps would be broken into 2. Okay, so that is how it is usually. The simplest thing is this: you observe something, it piques your interest, so you try to explain it away. You give an explanation. And how do we decide if the explanation is correct or not? By further observation. How do you further observe? By doing testing. But trust me, testing is a very, very, very important step. Because there could be 1,000 tests which may prove the hypothesis. But the test that disproves the hypothesis is the most important one. So anytime a scientist is proposing a hypothesis, he is trying to come up with a test that disproves it. He himself does that. Because if he doesn't do it, somebody else will do it, and his reputation will be on the rocks. So this guy will ensure that he takes care of his hypothesis better than anybody else first. So, as I say in science, you propose a hypothesis and then you are trying to look for things that disprove the hypothesis so that anybody can be, we don't waste time on this for too long and move on with a different hypothesis. So the sooner you disprove your theory, the better for everybody. So a scientific theory, a scientific hypothesis, I should say, a scientific hypothesis is it is trying to disprove itself, if you say. The proponent of the hypothesis is trying to disprove his own hypothesis before anybody else does that. And when a hypothesis has very good record of withstanding multiple tests, different types of tests, then you elevate that to the status of a theory. A scientific theory is a hypothesis that has not been proved wrong. You need to understand something here. You cannot prove a scientific theory once for all. You cannot do that. It's not a mathematical theorem. In the case of mathematical theorem, you can prove it. You prove it, you can have proof because it's logic alone. Mathematics has only logic. So you prove it. If a theorem is proved, then that's about it. Like there is no disproof can be given for that. But unlike in mathematics, in science, you cannot disprove a theory. You can have an increasingly high confidence in a hypothesis, so you elevate it to the level of theory, but you can never ever prove a theory. Why? Because science does not employ reason and logic alone. It also employs evidence. Mathematics is about logic and reason. Science is about logic, reason, and also evidence. When you say something, you must provide the evidence for it. It is not purely logic. You need to provide evidence. You can make any claim. You can make any outlandish claim in science. It's perfectly okay. You can even say that you fly to heaven every day. I'm okay with that. You may say that you come to college during the day and the moment you go back home or to your hostels, then during the night after dinner you fly to heaven and then party with the people of the heaven, the devas, Indra and other guys, if you're a Hindu. Then you come back every morning. Then you come and attend your college. So you can say that too. I'm perfectly all right with it. So that's a claim you make. You make the claim that you fly to heaven every night. I'm okay with it. All I'm asking you is to provide me with evidence. Can you give me credible evidence? You cannot just throw anything and everything at me and then say that is evidence. Your evidence must be credible, trustworthy. It should withstand scientific scrutiny. If you can provide me with credible evidence, then I will accept any outlandish claim that you will make. And this is the reason why you cannot prove a scientific theory. For example, we keep saying this. This is something that you know from your 12th standard. Nothing travels faster than light. So, do we know for certain? Do we know that? Can you prove that nothing can travel faster than light? No, you cannot. You cannot prove it conclusively. Like a theorem, you cannot prove it. But you can prove that everything else you know, everything else that is given to you, can travel slower than light. Electron travels slower than light. Okay, proton, any other particle you take, they travel slower than light. A bus, you can never accelerate it to the speed of light. You can never do that. So all these things that you say, from big sized things to minute particles, cannot travel faster than light. This we know. There could be a billion things that travel slower than light. We know that. Does it prove that light is the fastest moving thing in the universe? No, it doesn't. It just tells you that everything else you know and have come across is traveling slower than light. That is all it tells you. Do we have any reason to believe that there is a particle which will travel faster than light? No, we don't have any reason to believe it too. Well, if all these things that we know cannot travel faster than light, there is no good reason to expect that there is anything else that can travel faster than light. There is anything real that travels faster than light. And we have good reason to believe it. Okay, it is not, is it proven? No, it is not proven. See, the moment you find one particle, just one particle, that travels faster than light, that is the moment you throw Einstein's theory of relativity into the dustbin. But we have not found anything like that yet. And we have no reason to believe that there is anything like that in the universe, in our universe. But if there happens to be anything like that, trust me, Einstein's theory would be thrown into the dustbin. That is how science works. So you are looking for a test, an experiment that disproves a theory, disproves an already established theory. Same thing goes for Darwin's theory of evolution. Again, there is tremendous evidence available to tell us that complex organisms have evolved from less complex organisms, and in fact, all the way down to simple organisms. Simple organisms have given rise to complex organisms. We have lots and lots of evidence. It's not just one theory that he has put forward. We are not taking that theory at its face value. There is a lot of evidence. There is a lot of archaeological evidence. There is a lot of genetic evidence available to support the theory. There is a tremendous amount of gene match between a chimpanzee and a human. They say it's the difference between the set of genes in a chimpanzee and the set of genes in a human is only 0.5%. Okay? It's like 99.5% of genes match with the chimpanzee. So that slight change, that small difference of 0.5% of genes has given rise to a vast difference in appearance, in our processing skills, and everything else. And Aishwarya Roy's genes is away from the local chimpanzee in the zoo, is genes by only 0.5%. But an Aishwarya Roy is so beautiful and a chimpanzee is kind of ugly. I mean, depending on how we define beauty. But the basic difference, the structural difference is only 0.5%. But the outward appearance is totally different. And also you have Aishwarya Roy has language, and she's much more smarter than a chimpanzee. It's very intelligent. Humans are much more intelligent, infinitely, way more intelligent than a chimpanzee, if not infinitely. So, we have a lot of evidence there. And we know that simple organisms have only given rise to complex organisms. And we know the order in which they have evolved. But suppose you find one human skeleton, say 5 million years ago, Homo sapiens, like us. One human skeleton in an excavation which dates back to 5 million years. Darwin's theory will be thrown out of the window. But we have not found even one skeleton which does that. See, all it takes is one experiment, one little experiment to disprove a theory. But we have not found even one. And that is the strength. There are billions and billions and billions of confirming evidence for this theory. All it takes is just one evidence to displace Darwin's theory or to refine it. Why do I say that? They refine it. Let me take a simple example again. Okay, we have the theory of gravity. You take it, you take a pen, drop it, it falls. You take an eraser, drop it, falls. You take a pencil, drop it, falls. You take a stone, small stone, drop it, it falls. You take a big rock, drop it, it falls. And then you take a person, you drop that person falls. Everything falls. Okay, so you can keep repeating this experiment for thousands of times. So everything is falling. So you say gravity. All this is fine. Because you say the earth attracts this person. And suddenly, I do another experiment. I take a helium balloon. I hold it and then I drop it. So what is going to happen now? The balloon is not going to fall down, but it will fly up. What happened to gravity here? Why is the earth not attracting the balloon? Or is the earth not attracting the balloon? Then what else is happening? You see, the exceptions make you understand the theory better. And your explanation should account for all the other things and what is happening now. So testing is a very, very, very important thing. Okay, now you can ask this question. So if science is like common science, common sense, why is there such a difference between an Isaac Newton and an ordinary person? If an ordinary person is also employing the scientific method, and Isaac Newton was also employing the scientific method, why is this guy less successful, let me put it that way, less successful in his deductions than Isaac Newton was? Well, the answer is this. Though both apply the same thing, common sense, why it works for one person and does not work for another person? For example, let me take a Nityananda devotee. I hope none of you are devotees of Nityananda. Let me take that example now. Is that guy a fool? Is that did he not apply the scientific method? You bet he did. He has applied the scientific method to the conclusion that Nityananda is such a great guru or an incarnation of Shiva. That guy has used common sense. He's not going to listen to you and me, but that guy has used common sense. He has seen something extraordinary in him. Why would anyone follow a person otherwise unless he's convinced. So this guy is convinced that Nityananda possesses great skills, great powers. And what convinced him? And was he not applying the scientific method? No, he was. He was applying the scientific method. But the results that he got are totally different from the results you would get. If you were to apply the same thing on Nityananda, you would say, no, this guy is a complete fraud. You might say that. But another person may say that is not the case. This guy is a most trustworthy guru you can ever get in this world. That could be another guy's friends. Then what is going on? Why two people are coming with two different explanations for the same event or the same happening? That is because the success or the failure of the scientific method, which is nothing but common sense on steroids, told you, the scientific method depends entirely on the rigor in which these three steps are carried out. A lapse in any of these three steps, observation, hypothesizing, and testing. If there is a lapse in any of these links, they are like the links in a chain. The three-link chain is this. Then the method will fail completely. If your observation is not proper, if you have not observed something scientifically, properly, then you might conclude your hypothesizing would be wrong now. Suppose, let's say, there is a guru, he takes out Shivalingam out of his mouth. Okay? Well, your observation could be such that you think that's a great power, because there's nothing in his mouth before, now there is a lingam coming out. So clearly something amazing has happened. That is what you think. So you would conclude that this guy has supernatural powers. But there is another guy who observes this guy much more closely and then figures out that all that he is employing is magic, and his lingam is not coming from his mouth but from his hand, and he had hidden it somewhere else. So like when he takes the hand to his mouth, before he takes the hand to his mouth, he had already picked up the lingam from his pocket and then he's taking it there. But he makes it look like the lingam is coming out of his mouth. So if that observation is correct, then you are not going to have the hypothesis that this guy has supernatural powers. So if the observation fails, your hypothesizing will be wrong. Or your observation can be right, but your hypothesizing could be wrong. For example, you see the sun every morning to rise in the east and then to set in the west in the evening. So for you see that it rises there and then sets in the west. So it seems to travel this way. Then you can conclude, based on what you are seeing, that the earth is stationary, but then the sun seems to go around the earth. It's a perfectly valid hypothesis, right? If you think about it, your observation was right. Your observation was correct. Sun was there, and then sun moved. You didn't move. You didn't seem to move, at least. You seem to be at rest. But the sun seemed to move, and then it set in the west. So as a person who is watching this happening, you may conclude that the sun is revolving around the earth. Your observation was right, but your hypothesizing is not right. Why? Well, this one observation is not sufficient to give you the complete picture, which you didn't know, obviously. When you start this, you wouldn't know. I hope it's clear to you. When you start it, you wouldn't know. Like you are making one observation. Based on one observation, you come to some kind of a conclusion. Based on those observations, it's fine. The hypothesis is right. But the hypothesis is not right is something that you know now. But for a guy who lived, 2,000, 3,000 years ago, for him, it's very simple. He doesn't seem to be moving. The sun seems to be moving. So he concludes that the sun is going around the earth. It's perfectly valid hypothesis based on the available evidence. This is all the evidence he has. Based on this evidence, he has come to this conclusion. But if you need to alter this conclusion, and you know this conclusion, right? This is hypothesizing. That is wrong. You know this is wrong. But now you know it. Why do you know now that it is wrong? It is because you have many other pieces of evidence that suggest that this is not the complete picture. Okay. So you keep observing other planets and you keep watching the sky, and then you try to see what is happening to other planets and other planets in the solar system. You wouldn't even know they belong to the solar system and stuff then. But then you keep seeing things in the sky, then you would start questioning this hypothesis of the sun revolving around the earth. So you need more evidence. Okay, so the observation may be correct, but your hypothesis goes wrong because the hypothesis, your hypothesis does not meet the truth. That is because the evidence you had is not sufficient. The evidence was supporting this hypothesis, certainly. So evidence, hypothesis, fine. That's not the complete picture. So you need more evidence. So that is where the idea of testing comes in. Okay, if this is how it is, well, if the sun is going around the earth, then what else should happen? Is a question you're asking. Okay, then you predict, okay, if the sun is going around the earth, then how do you explain certain things? How do you explain the eclipses? How to explain things like that? Okay, there are many other things that you can go against this hypothesis. So then you conduct experiments. Then you devise experiments. Okay, let me try to see if this is happening. Okay, if this is correct, then that must be happening, right? So let me see if that is happening. If it happens, then it supports the hypothesis. If it doesn't happen, that is another observation, right? You are conducting a test to have further observations. Okay, so that test is giving you instances of observation, and if this doesn't meet the hypothesis that is coming that you have come up with, then you know there is something wrong with the hypothesis itself. Then you changed. But again, as I said, there could be thousands of tests that you may be conducting. They may be matching this hypothesis. They may be supporting this hypothesis. So you never know. Okay, I keep saying, in science you cannot prove something clearly, a theory fully. You cannot do that. You can only disprove things. A theory which is not disproved yet has very high degree of confidence. You will have a very high degree of confidence in that prediction, in that hypothesis, in that theory. But you can never be absolutely certain about anything. It's not just true for science, it's true for many other things too. it can never be absolutely certain. It is always, always a probability call. The world is built on probability. But that is the reason testing becomes important. I told you, observation has to be proper, then that should be proper. Second, the hypothesizing has to be proper, so you can go wrong in that step also. Even if the observation is right, you can come up with a hypothesis which is patently wrong. So that is where the creativity comes in. That's the art of science. The art of science is in hypothesizing. And the third step, testing. You are not going to rest on your laurels once you come up with a hypothesis. You are going to keep testing the hypothesis to see if there is anything that goes against it. If it goes against it, then you have a chance to refine the hypothesis and go closer to truth. Okay. So testing is a very important thing. And if your test cases, that is why your test cases are very important. If the test cases are not proper, then you would only confirm the hypothesis. If there is an inadequate test that you conducted, then you would only confirm the hypothesis and then you will stick with it. So your testing should always attempt to disprove the hypothesis. So, for a robust theory to come out of the scientific method, these three things, observation, hypothesizing, and testing, must work with maximum efficiency. And that kind of explains why we commoners are not very successful in applying the scientific method in daily life, even though we apply unconsciously in anything and everything we do. And as I said, from which movie you're going to watch to which guru to worship, which God to worship, you're applying this, or which party to vote, you're applying the scientific method. But then you're applying it inefficiently, inaccurately. And that is the reason you are not getting the desired results. But scientists are trained to find the pitfalls in their own observation, their own hypothesizing, and their own testing. That is why it is called as a scientific rigor. The method is applied so rigorously that it produces good results. The success of science is due only to the rigor with which the scientific method is employed. Employing the scientific method does not guarantee you success, because as I said, we are all employing it in a small or bigger way. But employing the scientific method with utmost rigor is what is going to give you success. It's a slow process. Science takes baby steps. But the success it achieves is phenomenal, and there is nothing that meets the majesty of the success of science. Nothing else in this world can come close to the majesty of scientific success. Now you also know, now that I've explained this to you, now you also know that different disciplines are called sciences because of this reason. Now you will also know what social science has in common with physics. Well, in physics, again, every statement in the textbook has been thoroughly tested. Every line has been tested and tested and tested by thousands of very smart people and found to be true. And that is why we call Einstein and Newton geniuses. Not because we don't accept things because they say certain things because those things come from Newton or Einstein. We don't accept things based on the personality. We accept things only based on the truth value of the claim. Why do we call these people as great, Newton and Einstein? Because many smart people have tried to disprove them and have failed to disprove them. Note that I have not used the word prove them. Nobody has proved them right. We have failed to disprove them so far. So that is the reason why they are considered to be such geniuses. And likewise, if you take social science, if you say that Rajaraja Chola was there, you must have evidence to support the theory. If you say that this guy fought that war and won, you must have evidence to support it. The moment somebody brings a different evidence saying, no, this guy didn't win the war, but somebody else won the war, but this guy was just cooking up information because he wanted to protect his own ego and reputation in his country. So that is why he has got that edict. But somewhere else, there is a conflicting evidence that suggests that this guy has lost the war. And that evidence can be verified independently to be true. So when something else comes up, then you alter it. So again, as I said, even in social science, even in history, every line that you see has pretty much some kind of evidence, conclusive evidence, or credible evidence, I should say, even if it is not very conclusive, a credible evidence to come to the conclusion that this thing happened. So that's called historiography. So the writing of history. You just cannot go and write anything that you want. But that's what these people want us to believe, right? I mean, they tend to say history is the is what the winner writes. No, that is not true. That probably was true once, but no longer. There is the scientific discipline of historiography, which has established methods in which any claim has to be validated. So you say somebody existed. If you say Ashoka existed, there must be evidence for it, a credible evidence for it. If you say this war was fought between these two people, there must be evidence for it. If you say that Indians invented zero, there must be evidence for it. So there must be evidence. So for every claim you have in even history, you have evidence, a credible evidence. And that is why you call it as social science. And you cannot say the same thing about poetry, clearly, right? If someone says that my lover's face is as beautiful as a moon, then clearly that is hyperbole, right? Hyperbole. That is, it doesn't. It's not true. Clearly, first of all, the moon, looking from a distance, may look fine, but it's so big, and it's full of craters. Right? A lot of potholes there. It's a municipality road on a bad day. It's like that. Like it's full of potholes. Okay, so if someone is going to have that kind of a face, you have to. I feel very sorry for them. Okay. So that is clearly this is not science. Like what you say is hyperbole. You're exaggerating things. You're not talking about truth. So poetry is rarely called as science. Yeah, there could be elements of truth in poetry, but poetry cannot be strictly taken as science. Like history can be taken as science. History, when written properly, can be taken as science. So that's about it, basically. The scientific method has 3 steps: observation, hypothesis, and testing. I call it as HOT method. Actually, it's OHT, but then for easy remembrance, I call it as a HOT method: hypothesis, observation, testing. But actually, it's observation, hypothesis, and testing. So these 3 steps will have to be carried out rigorously. So that is a scientific method. So any discipline that follows this method to create its common body of knowledge will be called as science. And a discipline that does not follow this method will not be called as science. Hope this is clear to you.